Hello, my name is Tom Hollingsworth, and I am a part of the Gestalt IT community. And we are here today to bring you one of our Gestalt IT roundtable discussions. These are topics that we bring up around enterprise IT technology, where we invite members of our community, as well as members from some of the suppliers of that technology, to kind of debate topics and ideas going on in the enterprise IT space, and hopefully give you a little bit of clarity about some things that you need to be keeping your eye on, or hopefully some things that you'll be implementing in the future. I'd like to take a quick moment for our guests today to introduce themselves so that you all know who we're talking to before we get to the actual discussion that's going on. So I want to start with Zoe.
Hi, my name is Zoe. You can find me on Twitter as RoseSecOps. What about me? I've been in the technology security industry for over a decade. I know I look younger than that. and I focus quite heavily on human behavior and embedding controls that actually are usable and solutions that are much more proportionate. Outside of that, I do a bit of volunteer work, and I've been upping my skills in BJJ.
Very good. JJ?
Hi, everyone. I'm Jennifer Minella, VP of Engineering and Security at Carolina Advanced Digital. I've been in the, I feel old now. I've been in the technology field for more than 20 years. And actually started off a very long time ago helping design and integrate systems based on Intel's platforms back then. So really excited to be here today. And throughout the time, I've focused a little more on the infrastructure side, so hard network infrastructures and the like of that.
All right, thank you. Scott?
I'm Scott Bollinger. On Twitter, I'm KFalconSPB. I do infrastructure and security for the Levitt Group out of Utah.
Awesome. And our special guest, Ron, do you want to introduce yourself?
It's great to be special. I'm Ron Perez. I'm a technology fellow at Intel, where I lead an architecture, security architecture and pathfinding organization, and I'm responsible for ensuring that Intel has wonderful security technologies for our customers in both now and the years to come.
All right. Well, thank you all for joining us today. As you can tell by the pedigree of the community folks that we've got on the call, as well as Ron, our guest from Intel, we're probably going to be talking a little bit about security. And the world has become a place where security is really something that we need to worry about from the very beginning of what we're trying to accomplish. When you look at the number of attacks that are taking place on a daily basis and the vectors that they're taking in order to be able to get to the data that they're looking for, or possibly even worse, it's becoming much more difficult to lock down the threat surface that we have to face on a regular basis. It used to be all we had to do was encrypt the data wherever it lived. And then it wasn't good enough. We had to encrypt it where it was moving between places where it lived. And even that isn't good enough now, because the people who are creating the most advanced malware in the world are able to grab the data in the middle of the transit from the memory of the systems that it exists in. So I want to start off by talking to Ron, because Intel has noticed this problem for the last couple of years, and they've been working on a solution that's very specific that integrates with their chipsets, Intel SGX. Ron, would you like to go into that a little bit and kind of give us the details around what SGX does?
Sure. I think you kind of alluded to the analogy of protecting data at rest, which we all know by now, right? You need to encrypt your data, sensitive data, especially, right, when it resides on a disk, especially if it resides on a disk in a cloud environment, right, that you don't control. We're all familiar with the HTTPS logo, the little lock logo on our browsers that tells us that there's some magic encryption happening behind the scenes to protect our transactions, right? If you're buying something online, for example, right? SGX, or software guard extensions, kind of takes that to the next level and focuses on protecting the data and the computation itself, the code, right, as it resides in a cloud environment, or maybe even an on-premise environment, but an environment that you may not necessarily have direct control over as the user or as the owner of the data in the workload. And the concept is, right, to provide isolation for this code and data, and only for that code and data that you care about the most, right? Not necessarily the entire application, not all the other applications on the system that might be running at the same time, not the operating system, the hypervisor, not even the other firmware in the platform, just the code and data you care about, and of course, the underlying hardware that's part of the Intel CPUs.
That's very interesting. I have a question regarding that. So what you're saying is I can choose to individually encrypt specific pieces of data. So let's say, for example, I want to encrypt my Amazon AWS API keys where they live, as opposed to encrypting all of the system that they're contained in. Is that something that I could do with Intel SGX?
Exactly, right. In this instance, you would have the keys. Either you would create them yourselves, or you would get them from a cloud service provider or someplace else, right? And then, of course, you would write your application in a way that whenever you use those keys to encrypt, to sign, right, to verify, right, whatever you're using these encryption keys for, you would write your code so that that portion of the code, and of course the keys themselves, only ever appear in the clear inside what we call an enclave. So it's a kind of a secure environment that Intel Software Guard Extensions helps you set up.
All right. I want to open this up to some of our community guests to kind of let us think a little bit more deeply about where this is something that could be used effectively in some of the systems that you work on, whether they be systems or infrastructure or, you know, security researcher type things.
I had a quick question, Ron. When you're working with multiple cloud providers, is there any chance that it might be transferred or might be used on a system that doesn't support SGX?
Yeah, no, that's a good point, Scott. Of course, right, this particular capability with SGX exists in certain classes of Intel CPUs, right? And we just announced our upcoming Ice Lake third generation Xeon processors that will have SGX natively, right? Prior to that, SGX has existed on some kind of single socket Xeon processors, right? But now we're really bringing this to a much broader audience and a much more scalable set of processors, right? But you really do have to have that processor and that capability to be able to take advantage of the software guard extensions, because it is a fundamental piece of the hardware itself.
And we find most of the cloud providers today support that?
So a lot of the cloud providers support the prior generation of Xeon processors that had SGX, right, the earlier versions of it, and more obviously all the big major cloud providers will be adopting Ice Lake when that comes out later this year.
Thank you.
Mm-hmm.
Ron, I had a question there because I know the SGX technology has been around for a while. I'm thinking like definitely more than 5 years. I'm thinking it's more like less than 10, but more than 5. I'm kind of curious what this next iteration or next evolution of SGX, what are some of the differences between the first iteration of that and then what we have now? Yeah,
no, that's a good observation, Jennifer. And you're right, SGX has been around for a while. The first research papers that describe the mechanisms and the capabilities came out in 2013, I believe, right? And then as a product, it showed up on client processors first, so your favorite PC devices, right? And the target was more like video chatting type applications, maybe some digital rights management type of capabilities. And the idea was that we would slowly learn from those more constrained environments on the client, right? Before we applied the technology more broadly to servers, and then of course to the cloud environments, which we're doing now, right? And our philosophy, of course, is that you really need to iterate on security innovations, right? Because you learn a lot, and we've learned a lot, right, over the last several years about what works, right? Zoe talked about usability. That's a hugely important aspect. SGX, while it allows developers to be very precise about what they want to protect, as I was talking to Tom about earlier, right? It also maybe puts the onus on people to know how to do that, to know how to segregate their applications and their sensitive code and data, right? Not everybody wants to do that, right? So now we're doing a lot of work with some open source initiatives that are more kind of lift and shift, right? That allow you to take your existing applications, rebuild them or recompile them so that they'll run inside of an SGX enclave without you having to do much more than that, basically, right? So it's really aimed more at the ease of use aspect and, of course, legacy applications, because not everybody really wants to refactor their existing applications, or not everybody is developing new applications from scratch for the cloud environment. So those are some of the issues that we're dealing with. And of course, to accommodate that, what we saw on the early versions of SGX was only a relatively small amount of memory that could be encrypted and protected, right, by SGX. I think it was 128 megabytes to start with. We've scaled that up slowly over the last couple of years, but with Ice Lake, this new third generation Xeon processor that's coming out, we take it up to 1 terabyte of protected memory, right? So that really takes, a lot of the onus off of the developers on having to manage, how they use this encrypted memory.
Yeah, I remember those early limitations.
Yes, yes.
I saw in one of the, I was looking at a couple, I think they were like marketing content in that. And the one thing I thought, the use case that I thought was quite interesting was regarding essentially sharing data without sharing the data, which sounds really silly, but essentially being able to have the data processed in a secure environment that both sides can't see it essentially, and then just deal with the output at the end. Obviously, well, not obviously, I'm in Ireland, but I clearly just came from the UK. And I think one of the biggest challenges I've seen quite recently is as the UK is leaving the EU and dealing with that data that they can't, certain companies can't leave the EU, so they can't be dealt with locally. I guess this is not a question at all, but I thought that was a really neat use case, because there's a lot of situations where I need to process data, and maybe I'm a global organization and I need to process all the data, but I can't actually show it to those people. So I thought that was a really, really cool kind of, I guess, use case that I could use it for.
No, I agree. I think that's the most cool use case for this technology. And in fact, I think we've seen that SGX, right, software guard extensions, has really been the catalyst for kind of a new trend, or new paradigm, potentially, right, in computing called confidential computing, right, where the idea is that you get these higher assurance privacy confidentiality guarantees in environments that you may not have access to and can't control, like cloud computing, for example, right? But you get very high assurances on the protection of that data without the cloud service provider or any other service provider having to kind of back up their claims of protection, right? Because it's really now the hardware that's providing these capabilities for you, right? And ultimately, it's on Intel right now to protect your data in this case, right? But as I said, this is a much bigger trend that is also kind of colliding at the same time with a growing number of regulatory regimes, right? You mentioned the EU, right, which has some tremendous privacy laws, right? Very good for consumers and for citizens, right? We have similar laws, right, in the US, and we're seeing them pop up around the world as well, right? The downside is that they constrain companies and even individuals alike on how they're allowed to move data and process data. So we can see that technologies like SGX now enable you to essentially compute on the data wherever it is, right, with these confidentiality and privacy guarantees, right? We have a couple of engagements, one that was announced recently with the University of California, San Francisco Medical Center, where they actually want to do drug exploration, right, a medical type research facility, right? And they're collaborating with us and with Microsoft Azure to be able to do privacy preserving machine learning, so analytics over data, right, that they collect and that other medical institutions collect, wherever that data resides, right? To give you another example, the University of Pennsylvania, we have a research relationship with them and 29 institutions where they're doing brain cancer, brain tumor research, right? And they are restricted on the data that these 29 institutions can actually share with each other, right? Yet they all want to benefit from the collective analytics, right, of over this larger data set to get much more high fidelity results, right? SGX allows them to run, right, the analysis on the data wherever it resides, and then merge it back into a set of results that they can all benefit from, again, without leaking the details of the data, right? So this is called federated machine learning.
Zoe, what you were just talking about with the information sharing without the oversharing and the confidentiality. I mean, I think Ron's just shared a few specific use cases that are really interesting, especially around healthcare and working with a lot of academic medical centers. I mean, I don't personally, but through consulting with clients, run into this a lot. Of course, I don't really have a good answer for them for it. That's not my area maybe Scott would have some better ideas around that. But this is something that they're dealing with. So it's not just, architecture. It seems to we're at the point now where we've reached the scale where this is actually solving problems. I know, banks have the same thing, and we look at it as consumers, and we think there's all of these companies and organizations and industries that are competing with each other. And while that's true, all of the different industry groups on the security side, the ISACs and the algorithms that they're using and modeling to make, like insurance modeling, right, and risk modeling, all of these companies on the back end are trying to find ways to share that type of data, whether it's, the utilities industry, the finance and banking industry, or healthcare. So I think this is an interesting technology, an interesting innovation for them to kind of move forward with those things.
Yeah, definitely. You mentioned, when I was talking about the medical example, but there are many others, right? In financial services, for example, some of these, make it easier, right, or more efficient, right, to process the data, to share the data, right, while others kind of, make something possible that just wasn't possible before, like some of the medical research that I mentioned before. The regulations in place kind of prevent a lot of these institutions from doing what they need to do with this data. And now these types of technologies like SGX, right, enables something that just really couldn't be done before. In the financial space, right, there's a lot of interest in some very expensive processing that they have to do today around anti-money laundering, right, and anti-terrorism regulations that exist between companies, right. And so here you can use SGX, right, as the basis to do processing of that data between banks and financial institutions and governments as well, right. Whereas, today it's a much more cumbersome and very time expensive option, right? That has to go multiple parties to vet all this data.
That kind of leads into my actual question this time. Is the one thing that I like, obviously, to read cyber news and everything, and what kind of comes up over and over again, especially when it comes to any of my auditing of cloud infrastructure or cloud deployments, is that planning prior to deployment, the by design feature. So obviously you had mentioned some cases, it might be a new rollout, but and so that might be a bit easier to implement. But how difficult is this going to be for an organization that has some infrastructure already, built in place, theoretically with the right hardware, of course, but how difficult would it be something for a team to maybe upskill to be able to deploy it, but also actually deploy it effectively, if that makes sense?
No, that makes sense. Yeah. And I think maybe I mentioned before, right, that, the fine-grained capabilities of this technology are really great, right, for people who know exactly what they're doing, what they need to protect, and they're writing their application from scratch from the first time. But, that's a smaller percentage of the world, right? The vast majority of the world is existing applications that maybe you tweak every now and then, right? But otherwise you don't even want to touch them, right? So we're working with the open source community, right, and many of our partner companies, right, on technologies that allow us to use SGX, right, and to basically rebuild the application, or take the application as it exists, even the binary, right, and put it into an envelope, right, which is protected now by SGX, so that it's, completely lift and shift, right, very low touch, right, that can exist in existing infrastructures, provided you have the right hardware, of course, right? But yeah, that's exactly why we're doing that, and why we're seeing a lot of interest there, right? But there's still a lot of challenges, right, ahead, right? How do we scale this? Do you get the same performance that in this type of lift and shift capability that you would otherwise get with a kind of hand-tuned approach, right? SGX also allows you to do. So, doing the analytics even on these tools, right, is important for us to tweak them and to allow developers to get the value that they need to get out of it.
Coming from a financial institution and an insurance background, it's kind of the wild, wild west in the United States, where every state has its own compliance laws and developing compliance laws on a day-to-day basis, where it's an international, it was a little bit easier because we would have countries coming up with like GDPR or such. Being able to control that at an IT level or at a company corporate level is going to help a great deal.
Yes, yes, and I think so. That'll kind of remind me of another aspect of software guard extensions that is very important, right? When you are using these kind of technologies, right, and they may exist in some cloud environment, maybe one of your bank's data centers, maybe several of your bank's data centers across different geographies, across different compliance regimes, even, right? You need to be able to remotely query the system and the application, right, itself to discern what the policy is, right, that's being enforced, right? And SGX has built into it this capability that we call attestation, right, which basically attests to the fact that that this particular piece of code and data is being protected by a legitimate Intel processor running SGX, and then it gives you a measurement actually of whatever you want to measure, right, the actual code, the actual data, the policy that's being enforced, right, and it's signed by the processor, right? So you have a guarantee from the actual hardware, not a person, not some convoluted software infrastructure scheme, right, designed to give you this capability, right? It's actually signed by the hardware, saying this is what's running, right? So you have a high assurance point of view of what's there, right? And you have that that greater guarantee, I guess, right?
Ron, I want to jump in here and ask a real quick question. For those of you out in the community who probably have heard about things that are, when they think about a good level of security, they probably think of something called end-to-end encryption, where, the data is encrypted at the source, it's decrypted at the destination, and in between, it's just a jumbled mess. However, end-to-end encryption has become a very hot topic for a variety of reasons related to regulatory entities that would like to be able to peer into that packet as it's flying across the network. Now, obviously, Intel's SGX and their confidential computing platform isn't necessarily end-to-end encryption. How does it differ, and how would this be more effective than that given certain circumstances?
Yeah, so that's a very good point, right? And I should point out that the underlying capabilities inside SGX, or the mechanisms there, are essentially that the hardware itself generates a key that nobody sees. No software sees it, no infrastructure, certainly not the cloud provider, and it uses this cryptographic key to protect that memory, right, where your sensitive code and data may reside, right? Nobody can get this key, out of the hardware, right? It's designed to be ephemeral. It's generated, as the system starts up, and for each application, right? So the idea is that now you have your application that may import some data, using traditional TLS or SSL, maybe some encrypted file, let's say, right? It imports that data into this SGX enclave, this protected environment, unwraps it, and then does processing on it, right? In all the time while it's encrypted by this hardware-generated unique cryptographic key, right? So if anybody, even if the cloud provider wanted to get access to that data while it's being processed, right? They could take the physical memory chips themselves and try to examine them. They would not be able to get a hold of the key that is actually encrypting that data, right? Again, right, whether this includes the cloud provider, maybe even local regulatory authorities, right, who may come in and say, hey, I'm seizing this data. They might be able to do that, right, in some geographies, but they still wouldn't be able to get access to the cryptographic keys.
Well, I'm going to put Scott on the on the spot for a second and ask, because I think you're probably the best qualified to answer this question, maybe. But I know we've had all of the conversations and the buzz around possible side channel attacks. I know when I first read the platypus stuff, of course, Tempest was the first thing that popped into my mind. Going back to the 40s, and
before your time, yes.
Yeah, that was definitely before my time. Just so
yes,
we're all clear.
before my time too, by the way.
But that entire that series of attacks of kind of extracting digital data from something that's a little more analog, with power processing and everything. I think that's something that's persisted through the decades. And I'm just kind of curious, from maybe Scott, if so before Ron, before you answer, I'm just kind of curious from Scott's perspective of living and working in that space a little more, what his thoughts or experience, what's hype, what's real, and what do we do about it?
To be honest with you, it things that I deal with day to day are just the fundamentals, the basics and such. I don't work in an industry where, we're getting attacked by state-sponsored we're crimes of opportunity pretty much. So I don't have much to contribute in regards to that.
Yeah, so maybe I can take it from there too, right? I think these, the type of platypus attacks, right, where they're basically doing power analysis, right, using capabilities that are on the chip itself today, right? The ability to monitor the usage of power, right? Those are very very ingenious attacks, right? And really take the power analysis attacks, right? The emission set of attacks, the Tempest class of attacks that you mentioned, right, to a new level, because now you're able to launch those kinds of attacks without investing a whole lot of money that you would otherwise have to invest to do something like that. And again, this tends to be the very sophisticated attackers to begin with, right? But now the question starts to become, right, are these attacks becoming more accessible to maybe not the script kiddies, right, but certainly to some moderately sophisticated attackers, right? Maybe even hackers.
The script teens. Maybe.
Script teens, yes, there you go. Yes.
Thinking adults.
Yeah. So I think these it's important for us to not just monitor but to engage with the community on solutions in this space, right? Since the Spectre meltdown situations happened, right, a couple of years ago.
And I imagine that the research community is always so helpful when it comes to this, because they do.
Yeah.
I mean, I know that the groups that we deal with, they follow responsible disclosures and they want to help, right? They're there to help protect things. But I think it's interesting, and the only reason I even kind of poke and pick into something this specific is that, I think a lot of security controls that we work with, or at least I'm going to just speak for myself because I don't know about you two, but a lot of the security controls I work with are meant to be, you're layering them and you're just trying to not be the door that's unlocked when somebody comes, right? You just make it a little harder and don't be the low-hanging fruit. And frankly, when you've done that and you've followed best practices, a lot of the rest of it is luck to a certain degree. And I hate to say that, but it is. But when it comes to the technology that we what we could be doing with an SGX, we could be doing with like in-memory encryption, is now we're starting to talk about having some tools and controls and technology in place that helps us when somebody is coming directly after us, when it is a targeted attack, when somebody is coming after our IP or doing something. So I feel like there's this whole set of use cases, like Zoe hit on one with the sharing of the data, and I liked your examples in healthcare. And I think just the idea that we can have stuff somewhere else in the cloud, and we don't have to feel like we have our hands wrapped around it to feel like it's secure. I think that's a warm fuzzy. But then I also feel like there's this whole other side of the coin, which is when somebody is attacking us and we have something that's that valuable, and that's not every organization, right? That's a tip of an iceberg kind of thing. We have something that we can do to protect ourselves, at least to a certain degree. And so when we're that type of organization, we are really interested in what an attacker might be doing to work around that, and how do we continue that cycle of, like you were saying, iterating the innovation.
Yeah, no, that's an excellent point, and I think goes back to the importance of defense in depth, right? Not just in having multiple layers, but you should never rely on any one security technology for your protection, right? Especially if the data that you're concerned about, the processing that you're concerned about, is highly valuable, right? That you may be a target, right? It's great that we're addressing some of these legacy application scenarios and lift and shift sort of capabilities, right? But at the same time, if you take basically badly written software and put it into a secure environment, it's still badly written software. It's still going to have bugs. It's still going to be vulnerable, right? So you have to take the time and effort to presumably, if you really care a lot about the processing and the sensitivity of this data, you have to take the time and effort, right, to go that extra mile, let's say, right, to do what's right in terms of disaggregating your code, right, and architecting it with security in mind. So SGX hopefully allows those developers, right, at that high end, that high level of sophistication range, right, to do that, right. It has lots of knobs, right, so many that probably frustrates a lot of people, right, but allows those people who really care the most to do that, while at the same time allowing just your common everyday, right, cloud application, whatever it is, right, to be secure and to get some of the same benefits of this technology.
I would like to say that I prefer to call it unlock of the draw, where you unluckily the one that's targeted or breached, but I kind of that defense in depth bit and that kind of looking at trends currently. What I've noticed is a lot of people, shockingly, are a bit bored, and I am curious about in the coming future where financially people maybe aren't doing as well as they wanted to because of what's going on. A lot of people have lost their employment. Again, as you mentioned, as we develop and our understanding of different technologies, attacking becomes almost easier. I'm not saying it's simple, but there are some things like little small failures along the way that we didn't do those foundations properly. That actually there are pre-built tools out there. You don't have to be this super elite hacker. Or cyber criminal is more accurate, but the one thing that kind of stood out to me was that applying it in a way that works without having to think, if that makes sense. So, you put it in that secure environment, and yes, it does have to still be, legitimate code. It can't be really sketchy, but it's still that kind of adding that confidence of the integrity, adding that confidence that if some other control is failing, you've still got that there. And I mean, recently, I'm pretty sure today or yesterday, I read about another recent breach that was a cloud infrastructure that they didn't quite think from the start we should actually apply these security or privacy controls by design. So one thing I also think that this technology is benefiting is not just actually working, but getting that communication, saying, this works not just in transit and not just at rest, but actually in processing, and why that matters. From my experience, I've seen tech struggle quite a bit to communicate to the senior leadership that reason for why it needs to matter, why it needs to be applied, and why they need the budget for these different controls. Have you seen that this solution maybe has helped with that communication, along with obviously the regulations, but having that this can do this feature and why is this important?
That's an excellent point. I think before these types of capabilities existed, like with SGX, for example, right? Maybe the technology community, wasn't as interested in going out to tell people about, these are the vulnerabilities, right? That we're not addressing, right? Because you're very focused on, the latest technology you have and how it addresses, these sets of vulnerabilities, right? But there's a whole class of other vulnerabilities, right, that you're not addressing because you don't know how, you don't have the technology to do that, right? So certainly, right, now that we have something like this, right, we're seeing a lot more people. Well, first of all, we're able to explain, right, this technology and what the value of that is much better to our partners, to our customers, and to the rest of the industry. But also, we're getting much more feedback from that ecosystem, from these stakeholders on, oh, well, this is really interesting, right? You can provide this capability on a general purpose computer, right? But workloads are getting more heterogeneous now, right? I want to use a GPU too. I want to use some other kind of accelerator, right? Can I get this benefit there? Well, the answer is not yet, right? Today, right, you have it on an x86 CPU from Intel, right? But it gives us something to work for now. How do we extend these capabilities beyond the CPU to include, GPU, to include various AI accelerators, right? And I think Intel is probably very well situated as a company in terms of our product portfolio and all the breadth basically of the products and technologies that we're in, where we can start to apply these technologies, right, across the board, right, so across this distributed data center, heterogeneous data center. Yeah.
Hey, Ron, I had a question to build on that. So you have a workload deployed. How does the technology handle if the workload is transferred to something that doesn't support SGX? Does the application just fail, or is there some kind of it'll work but just not as designed?
No, it really won't work at all, right? The application, if it's using the SGX instructions, for example, the processor, right? If it's another Intel processor that doesn't support SGX yet, right? basically those instructions will fail, right? The application will know right away on which platforms it can be used on and which it can't.
Okay, thank you.
I think we're going to have to go ahead and wrap up here. There's been a lot of great questions from our community guests, as well as some of their viewpoint and perspective on the confidential computing ideas that Intel's putting out there. I know that Intel SGX is an interesting component of what's going on. Ron, if people want to learn a little bit more about what Intel SGX can enable and possibly some of your other partners out there in the ecosystem, where's the best place to go to learn more about that?
Yeah, so there's actually, especially if you're concerned or want to learn more about the assurance, right? The confidence, I think, is what Zoe said, right? Which is a very good word here, right? There's an Intel.com Trust SGX site as a good starting place to start learning more about that, which vulnerabilities it addresses, right? Where the challenges remain, and really how to use this this capability as a defense in-depth capability, right? And we also have other websites, right, on Intel.com that get into much more detail about how it's being used today. I mentioned that the various healthcare, the UC San Francisco engagement, the University of Pennsylvania engagement, right? Some work we're doing with Microsoft Azure, with some other customers in the financial systems space too, right? All of those examples can be found on Intel's website, and we can certainly provide those links to you.
All right. Well, thank you very much. We'll make sure to include a link to that in the show notes as we get this video published. I want to thank everyone from the community for joining us on this call, and I want to thank Ron from Intel for joining us as well. It's been a fascinating discussion. If you want to hear more discussions like this, more of our roundtables, please make sure you head over to our website at gestaltit.com. You can also follow us on our YouTube channel at youtube.com/gestaltitvideo, where you can see more great content like this. But for myself, Tom Hollingsworth, for our great community guests, and from our special guests, I want to say thank you very much, and stay tuned because we will be having more great technology conversations in the near future.